Hey everyone, welcome to this edition of the Agronomists. I am your host, Lindsay Smith. I'm a little blurry on my end. Maybe that's just today. Okay, it is mid-August, and yes, this session, Peter Johnson, is all about wheat, but specifically insects of wheat. And so I am incredibly excited for tonight. But of course, before we get rolling with our guests and tonight's topic, quick shout out to everyone joining us across all our different platforms. Please let us know where you're watching from, what's the crop looking like where you are. And if you collect those CEU credits, make sure you head on over to realagriculture.com/agronomists. Tomorrow morning, we will have this episode up and you'll be able to apply for those CEU credits. So yes, don't forget to do that. And a big shout out to our show sponsors for tonight. Our show sponsors are ADAMA Canada, Wheat Pete's Word, and the Wheat School. ADAMA Canada, while other sources of innovation run dry, ADAMA is here to deliver, leveraging the world's largest library of actives to provide innovative crop protection solutions to your greatest challenges. We're all in on you. Talk to your ADAMA sales rep today. Okay, let's get into it, everybody. I am super excited to have my two guests joining me tonight. Here I've got Tyler Wist with Agriculture and Agri-Food Canada out of Saskatoon, and Jeremy Boychyn with the Alberta Wheat and Barley Commissions. Welcome here, gents.
Hey, thanks for having us.
It's great to be here, Lindsay.
Okay.
Yes, also great to be here.
Yeah, and thank you so much for doing this. It was rather last minute, so thanks for saying yes. For anyone who's worked with real agriculture for any length of time, you'll know that that's kind of how we roll. We tend to do things a little last minute, but that keeps it timely and keeps it interesting. And yes, Peter Johnson, you are a sponsor of tonight's episode with Wheat Pete's Words. We'll have more on that a little bit later. Okay, I'll start with you, Tyler. In Saskatchewan, how are things looking where you are?
Well, I looked at my wheat just a few days ago and it had all turned, and I got really sad because that kind of means the bug year is over.
Oh. Entomologists are weird, man. All right.
Totally,
right. Jeremy, whereabouts in Alberta are you based? What part of the province?
Yeah, so I'm about half an hour north of Calgary, in the Carstairs, Didsbury area. And, you know, around here, things are moving pretty quickly. I was out to Innisfail, Irricana this past weekend, and man, things are starting to turn. So we're getting to the end, and I know there's producers in the southern part of the province that are already moving on some pulses. So things are moving quickly.
I planted some really late pulses, so I'd still have bugs to look at today.
That's called planning ahead, Tyler.
Totally.
Well done.
Full of aphids. Yeah,
exactly. Great. Your version of great and like the average person's version of great are very different. That's what we're going with. Yeah.
Well, I'm studying them, so I need them.
It's true.
Last year was terrible. They burned. All my aphids burned last year.
Every last one of them. Jason says Tyler is thebomb.com on insects. You should probably trademark that and put it on a shirt. We'll get to some cool shirts in a moment. And shout out to Lara de Mozak, who's also watching and trying to cook steak and pay attention to this at the same time. Lara also does love insects, so she should be perfectly fine cooking steak and doing this. You can pay attention, Lara. You'll be fine. And these ones aren't that gross, but there are a few gross moments, I think, to come. Because we are going to talk about wheat midge and we are going to talk about sawfly, and there are some really cool things about both. So let's get into it. Maybe we'll start with wheat midge, if I may. And maybe we'll start with those maps that we very quickly threw together just before this program. Yeah. Right. So right. Let's look now. Apologies to Manitoba, but let's look at Alberta and Saskatchewan because that's who's repping tonight. And
no need to apologize for Manitoba. They don't do a survey.
Well, okay. Are we going to get political, Tyler? Okay.
No.
So let's look at the Midge forecast. Wait, there we go. The forecast for 2022. This is what was, and then in the middle is what is. So, Tyler, I'll start with you. If you want to speak to the Saskatchewan side, it didn't look so bad except for what the heck is that one anomaly there in the middle?
Oh, yeah. So,
what's that about?
Let's start with the left, though. We always read right to left. Alberta's,
I don't know. Yeah.
unless Alberta's up on the left, and as we can
Alright.
see there, the map looks mostly green, right?
Yeah.
Green's that nice happy color, but caution, that bright green there, which is getting closer to Rough Rider.
Oh,
The
Uh-oh.
there we go.
Oh.
Oh, there you go.
Is-
Tyler, you're back.
oh, did I freeze up?
You did a
Oh,
little
my
bit, but
apologies.
we're good now. It's okay.
I got a new router today. I thought that was going to fix things.
It's warming up. Give it a minute.
Okay.
It'll
So,
be fine.
well, let's go back to the Rough Rider green areas. You know,
Yep.
they're verging on Rough Rider green. And those really pale green areas, those are the ones where there was no wheat midge found. So when I say no wheat midge found, this was Shelley Barkley on the left going out and surveying a lot of wheat fields with a soil core. So she'd be out there, she's digging these little soil cores, she's bringing them back to the lab, and she's washing those out and counting the number of wheat midge overwintering cocoons that are in there. Lots of work for this map. And those brighter green areas mean that we've got less than 600 per meter squared. So when you do the math, it works out to less than 300 or 600 per meter squared. And so that doesn't mean there were no wheat midge in those. There was less. I froze again.
It's okay. You're back. Yeah. We're going to have some
Good, good.
hiccups. We're just going to roll with it.
Looks like
What
it.
we do.
Right. So it's not like you're out of the danger zone there. It just means that there should be less wheat midge in those bright green areas than should be able to cause damage the next year. So this is what we want to see. 2021, we did not see that. We saw some bright red areas. We saw some really hot orange areas. So as the color gets angrier, the more wheat midge we have in the fields on the wheat midge forecast. So up on the right, Saskatchewan was about the same in 2022. But if we threw up the 2021 map, it looked like the perfect storm was happening. So with the right combination of rain and those forecasts meant we could have a big wheat midge year. And so I was giving a presentation to CCAN on wheat midge, and they said, hey, how about we call this 2021, potentially the perfect storm? And I said, well, that's cool, but we don't really have a way of measuring whether or not those wheat midge emerged from the ground. And I said, wouldn't it be cool if all of your CCAN growers put up a wheat midge pheromone trap in their field? Then we would actually know when emergence started and how much emergence you actually got. So I'll qualify that with the wheat midge pheromone trap. What it does is it catches male wheat midge, but it shows you when they start coming out so that you can get out in the field and start scouting. So this was a double benefit for the producers. We'd be able to see when emergence started, and they could tell wheat midge they had in their field and get out in the field and start scouting for those females on the heads. So that 2021 map, we actually did have all those really red pockets when there was sufficient rainfall. It happened. The wheat midge came out of the ground and emerged. And in those areas, which was down in kind of southern Saskatchewan, southern Saskatchewan, they got a ton of rain over about a 4-day period, and that brought the wheat midge up and out of the ground. Then the drought hit later, but the wheat midge had already come out. Then up in the northeast, like around Melfort, Tisdale area, they did not get a whole heck of a lot of rain in May, and the wheat midge didn't come out of the ground. So here's what we're seeing this year. This is wheat midge Busters 2.0 or 2022, right in the middle. And these are actual emergence numbers. The intrepid Ross Weiss, who does all of the PPMN, Prairie Pest Monitoring maps, he put this together for me. And those hot red areas that we can see right there, those are areas where we had a lot of wheat midge come out. So this is cumulative trap counts of male emergence. So CCAN, thanks very much for getting on board again and sending out all these traps. And all the growers who hosted these traps, thanks very much. I know in those red areas, there was a lot of counting. So I really appreciate that. And I hope it was of value to everybody.
So, but when I look at this versus what the forecast was, they don't really match up at all.
They don't match up. No.
No. And Jeremy, Alberta is a mess. So what has been your experience this year with Midge in the province?
Yeah, I mean, these maps, especially seeing, so this is my first time seeing this Midge Busters
This
map,
one,
so
yeah.
I'm taking this in at this
Well,
point
it's
too.
everybody's first time. And we made it like yesterday.
It's a premiere. It's a premiere.
Maybe this
But anyway,
morning.
yeah.
So
there you go.
I mean, May was, especially in that red area around Calgary, we were dry. We really didn't get any rain until June. So when we talk about Midge and
All you
emergence,
need
it's
is
always
one
that-
big rain.
Yeah, so it must have been those June rainfalls that came that pushed that out, because I mean we were pretty dry in May. So were those the rainfalls that actually caused that emergence, Tyler, or could it have been something still earlier than that?
Ooh, I'm gonna say analysis yet to come. So what I can do with this data is I can go back and I can take a look at the Environment Canada rainfall that actually fell and see what happened there. But I haven't done that yet. Last year I did. That's how I was able to chat about the Northeast and Southern Saskatchewan.
Right.
Hey, Jeremy, what happened up in the Peace River region? Because I had some reports of just heavy wheat midge.
Yeah, I mean, we did have some, like, again, there was pockets of moist and dry up there. So I'm curious to see the amount of spread that, most of it is looking orange. Again, I wouldn't have expected to see this kind of response with kind of the variability in rain that we saw, especially in May. So it just makes me wonder, what's at play here, that maybe what we're actually seeing in some of these catches, is it aligning exactly with that May rainfall? Because we did have people scouting and we did get reports of it, but it just didn't seem to align with that May rainfall that we would have expected.
So and to that point, when farmers and agronomists are trying to anticipate exactly that, as you mentioned, Tyler, if we're trapping the males, then that gives us an indication of that they're out, they've emerged, they're flying. So the forecast wasn't bad, but we've got some pretty bad areas. So how much weight do we put on the wheat midge forecast, or how can we use something like a forecast as part of our scouting and our management tool?
Well, we're just starting to scratch the surface on this Midge Busters versus the forecast map. So this is the first year where, this was kind of shocking.
Okay.
Last year, it did actually match up really well with the forecasts. So don't forget that wheat midge can sit around in your field like a bomb, a ticking time bomb, until you get those rains. So I think maybe what we're seeing here is that ticking time bomb just coming to fruition. Now, look at some of those big red areas. Those are heavily influenced by about one trap. So because this is smoothing, right?
Yeah, so Peter wants to know if those black dots on that map, Jay, can you make the middle map a little bit bigger?
That's right, Peter. Each of those black dots represents a trap,
Okay. So
and a producer who is counting. So thanks to you guys.
Yeah.
Up there in the piece, I'm going to give a shout out to Danny Limages, because he phoned me and he said, Tyler, I've got all these wheat midge on the trap. It's taken me forever to count. And I said, thank you, Danny. Will you go out and look for females in your field? And he said, no, sir, I can't do that. It's too much time. And then he went out and did it. And what he found was he had 3 wheat midge on each head, which is way over any kind of threshold.
Wow.
Yield threshold, we're looking at 1 wheat midge on 5 heads. So the midge trap alerted him to a problem in his field. And so, I mean, for that is one of the reasons why we had hashtag MidgeBusters. So you can follow that on Twitter. We called it hashtag MidgeBusters.
I think this really speaks to the importance of just being aware and continuing to scout in your field. Even if that forecast map comes up and it's not looking as green as it historically could, if you are in that historical area of seeing wheat midge, it's good to get out and scout and actually see what's going on and maybe get a hold of Tyler and put up a pheromone trap there as well. I'm sure he'd be happy to share it with you so you can get an idea. But, this is where it becomes super important to make sure that you're getting out in the field and actually seeing what's going on, because, and compared to Saskatchewan, the percentage of varietal blend midge tolerant wheat varieties that we have is a smaller percentage of our wheat acres. So this is a lot of potential fields that are being impacted by wheat midge. And if we're not out there scouting at the ideal times, we may not be able to mitigate some of the impact. But also, then taking that step of, if we're seeing this kind of spread, and if this is representative, implementation of more of those midge tolerant varieties is going to be valuable to more producers. So again, that can be a decision that you make when you're out there scouting, assessing what's in your field, and then working with those seed growers to see what's a viable option of a variety in your area.
I'm glad you brought in the midge tolerant wheat, because that's important, right? Yeah. This map shows us that you can't be complacent on wheat midge.
Okay, so when that's I guess where I want to go with this. I am going to go to the clip. We'll get Scott Mears to sort of weigh in on some of this midge stuff as well. But when we come back, I want to talk about we have clips. I do want to talk about the varietal blends and just Tyler, I'll ask you to walk us through the wheat midge sort of attack and life cycle kind of and bring all those things together, because it is a really interesting management tool. Especially compared to sort of how we manage other insects in agriculture. So I do definitely want to do that. But Producer Jay, if we could go to the clip with Scott Mears and Kara Oosterhuis talking wheat midge.
Yeah, so wheat midge, really the scouting period is when your crop comes into head, when it first starts to head. Up until the anthers come out, so that's at the anthesis, what we generally refer to as anthesis. When the anthers come out or flowering wheat, up until that point, the wheat is susceptible to wheat midge, egg laying, and the early development of the larvae. So scouting is from early heading to anthesis.
What sort of conditions does wheat midge like?
Wet. So central Alberta, a little bit wet this year. Delayed seeding tends to play into the emergence of the wheat midge. So we see wet conditions and late seeded crops in central Alberta. So it's a high risk situation coming in this year. The only good side is there's not a massive big population out there. But if you look at the Alberta wheat midge map and even into Saskatchewan, there will be individual hotspots, individual fields that are higher risk. So overall, the population is low, but it's going to be important to scout for midge this year. Delayed seeding, crops that are slow growing seem to be lining up better with the wheat midge population for 2020.
And what does the wheat midge actually look like, and how do you scout for it? Can it be swept, or how do you gather that info?
Sweeping is drastically ineffective. So not sweeping. You're out looking at crops as the evening sets in. So that time of evening when you feel that moisture coming up off the soil, that's the ideal time to be looking for wheat midge. So you have to be out in the fields. What do they look like? They look like miniature mosquitoes, basically. And you will be fighting mosquitoes as well this year, especially in central Alberta. But they look like miniature orange mosquitoes, and they fly much the same as a mosquito. They kind of hover around, and then they'll light on the plants, and you can tell that they're orange when they do that.
And are there any beneficials that attack the wheat midge?
Yes, there's that one you can sweep for. So during the day you can sweep for, it's a little parasitoid wasp called Macroglens penetrans, no common name, but it's quite an effective parasitoid, but it takes a full year for its life cycle to catch up. So typically, we're not seeing any help from the parasitoid in the same growing season. So it lays an egg in the egg of the wheat midge, and it hangs out in the wheat midge right up until pupation the next spring, and then it kills it at that time. So a delayed benefit, I guess.
And what sort of economic thresholds are there out there for wheat midge right now?
Yeah, so fairly well-defined thresholds. 5 wheat midge one wheat midge and 5 wheat heads when you're doing your evening scouting. Is the threshold. If you're worried about grade protection, it's 1 wheat midge and 10 heads, and simply you just go out and you look at 10 heads, how many wheat midge are associated with that, and then you check a couple more spots in that area and check several spots in the field to get your read on the numbers. So yeah, it's a fairly well established 1 in 5 wheat heads is the threshold for yield protection.
Okay. Anything else you'd like to add?
Just spraying is fairly critical timing. You want to be checking close, and then if you have to spray, you should get in there and spray. The most effective management of wheat midge is actually midge tolerant wheat. So if you're in an area that is typically a midge area, you should be looking into and using midge tolerant wheat.
So my guests and I have a chat while these things are going, and the winning comment is those shelves go up very high, so high that if a book fell from the top, it would kill you if you were standing at the bottom. So there you go. Okay, before we get back into that is a lot of books. Very impressive, Scott. Before we get back into the show, I do want to send a shout out to our show sponsors, of course, ADAMA Canada, the Wheat School, and Wheat Pete's Word. So if you, and Peter Johnson has joined us here tonight. So if anyone is looking for a Wednesday listen, you can download Wheat Pete's Word. It's a podcast, goes up every Wednesday, and you can send Pete your agronomy questions. You can email him at pjohnson@realagriculture.com, or you can follow him at Wheat Pete on Twitter, or leave him a message 1-888-746-3311. Okay, let's get into it. So Scott did, of course, cover a lot in a short amount of time, so we're going to dig in just a little bit more. Tyler, I'll start with you quickly. So he mentioned the parasitoid, and so I want to talk about that just a little bit, in that he did mention that, of course, it takes, and we know this, predators and parasitoids are often sort of they have to catch up, right? They're a little bit behind. So can we count on those parasitoids? Do we want to preserve them? How do we manage, encouraging those parasitoids in our crops?
All right, that's a great question. So this is one of our field heroes, and put a shout out to the @fieldheroes on Twitter and fieldheroes.ca. So this little parasitic wasp, like Scott said, and I'll just qualify this with, I'm pretty sure Scott stole all my lines, so I might as well just sign off right now.
No, nonsense.
Maybe I'll stay on.
Yeah, we still have Sawfly.
So that little parasitic wasp goes after the eggs, and it goes after the first instar larvae of the wheat midge. So you got your males coming out. About 3 days later, the females come out. The males find them. Beautiful music plays, and then you get eggs and you get larvae. And then about 7 days after those initial males and females have come out, then you get the parasitoid. So it's really well synchronized to finding those eggs and those larvae. So, and like Scott said, you can sweep for those. They're little black specks that you'll find. No, they're like this small. They're tiny. And they fly during the daytime. So you can see them during the daytime, and they'll be crawling around on the wheat heads. So if you see a little black wasp, that's probably what you're seeing going after, unless you got a ton of aphids, because then you get other little black wasps looking at it. These ones are very different, though. They're in the family Pteromalidae. And so they're kind of a little shiny black with a pointy abdomen if you get them under a microscope. So then they just hang around in the body of the wheat midge until the wheat midge overwinters. Then in the springtime, you get those rains, and instead of having a wheat midge adult emerge, you get a parasitic wasp emerge. And typically we get about 30% of the overwintering generation of wheat midge killed and controlled by that wasp. So like that wasp saves people like $230 million a year in spraying by keeping the numbers down.
See? Field heroes. Okay.
Field
Okay,
heroes,
quickly.
exactly.
Yeah. Okay, but quickly, when Shelly goes through and does and like extracts all those from the soil, from the sampling, can she tell which ones have parasites?
Yeah, Shelley describes it. So I'm talking about Shelley Barkley, Alberta
Yep.
Agriculture. We do it in Saskatchewan as well. We have a contractor contracted by the provincial government, paid by Sask Wheat as well. So those cocoons come back, those overwintering cocoons, and they actually pop them open with pins. So you squeeze the wheat midge. If it pops open and you see a little parasitoid larva, then it actually comes not a viable wheat midge. So
Yeah.
they don't get
Okay.
counted, but they do go into the Excel spreadsheet.
Yes.
And
Okay.
if I ask nicely, they'll share those Excel spreadsheets with me.
Right.
And
Okay.
the parasitoid population was actually going down in Alberta last year. So we were a little bit worried there. Like they were down from 30% to about 8%.
Okay. Lara
And that's
says,
interesting.
parasitic wasp, my homeboy, my sweet cheese, my good time boy. That's right. We love our parasitic wasp. Okay, so Jeremy,
Oh, yeah.
Interesting that the parasitic wasp
Well,
is
I was
going down. Why?
With populations going up, like with more opportunity to parasitize, we've seen these populations go up as other than this year. I mean, depending on where things land, but we would think maybe there'd be more opportunity to parasitize. Do we have any theories on why we're not seeing as much parasitism?
My two theories: we haven't had that many wheat midge. It's been kind of dry. So when your prey goes down, your predator can go down as well. Plus, we're planting varietal blend midge tolerant wheat, which can reduce populations because now you've got 90% of the wheat midge larvae in your field because 90% of the heads are now killing those wheat midge or making the kernel of the wheat unpalatable, let's say.
Right.
Doesn't straight up kill them. It makes it taste terrible and they starve to death because they stop feeding. What a way to go.
So, okay, what a way to go. Not a concern for me, just so everyone's aware. Okay, so Jeremy, just quickly walk us through what a varietal blend is. I mean, for those of, our friends here in Ontario watching, it's sort of like refuge in a bag type idea with corn, rib, whatever. So how does a varietal blend work for this pest?
Yeah, so varietal blends, when it comes to midge tolerances, we have these varieties with the SM1 gene, and that SM1 gene is what Tyler's describing there is unpalatable. But if we kept that variety as a pure variety and seeded that into a field, and there's midge there's going to be a large enough population that there's going to be a small percentage that would end up essentially feeding on that SM1 carrying variety. And then they would repopulate, and then that resistance would be broken. So to avoid that, we put in 10% refuge of a non-midge tolerant or SM1 variety. So then we have preferential feeding on this non-SM1 variety. And then we essentially significantly reduce the potential of a midge feeding on that SM1 variety and getting past that resistance. So it just allows us to vastly extend how long that SM1 gene can be used for resistance, which is why it's so important, because that is the only level of resistance that we have to work with right now. How this is set up, the amount of refuge that we have in there, and the only 1 year pass certified that comes with growing a varietal blend is all important to make sure that this system of resistance stays in place.
Right, because that is, to recap, it is a single gene. So a single gene resistance is easier for those insects to overcome. So this is really about stewardship of this trait and keeping it around as long as we can. So really key there. Okay, before we move on, because we do want to talk about Sawfly, Peter Johnson wants to know, Dr. Tyler, why is wheat midge not really an issue in Ontario? Because Sawfly has shown up. Why is wheat midge not an issue there? Are we just blessed?
Well, you do have wheat midge in Ontario. I'm sure I've heard of it from mon ami Julien Saguez, qui travaille avec Serum. He's in Montreal. So I just
Not
dropped
far
into
from where I
French
am.
there for a second.
Yeah, I liked it.
So
Good job.
we've got, there's wheat midge out there. Why is it not an issue? Maybe you guys don't grow enough wheat. I don't know.
Are you sucking up to Peter Johnson? Because I feel like maybe you are. It's a good question. Peter, maybe we should put out some traps and see what we can find. I
Good idea.
volunteer to put up traps because I have.
All right.
I will say, Tyler, you're probably right. We probably don't grow enough wheat. I will say in my area, so I'm just west of Ottawa. And this year, I would say we actually have had a lot of wheat and even quite a few spring anchors that went in. So I guess we'll see if that's going to change at all, if it's highly specific to the area. But I would gladly put up a trap. Okay, we do have to shift
Thank you.
gears because, of course, yeah, we do. I do want to talk about Sawfly. Okay, who wants to start? Actually, Jeremy, you're going to start because you've got some gross pictures of very large wheat, and we do have some great pictures of the Sawfly, and of course, in the stem, we've got some larva pictures. So yeah, super cool here. But start with, what is Alberta facing here with wheat stem Sawfly?
Yeah, so this was taken a couple years ago, and maybe those listening who don't know what wheat stem sawfly is, essentially, in short, and I'm sure we'll get into more detail, it's an insect that lays its egg in the stem of that wheat. It produces a larvae, which grows down or feeds down that stem and gets to the bottom of the stem, and then kind of notches a little hole in the bottom of the stem. And I'm definitely shortening the description here, but essentially what that does is it weakens the stem. And then when we get to the latter part of the season, we get storms or any kind of heavy crop, it'll push that crop more easily over, and then it becomes a harvestability issue. But also we've lost yield because when the larvae feeds through that stem, it's reducing the amount of energy that can move through there. So we have a yield reduction, we have harvestability impacts, and it just becomes an absolute nightmare. So this is actually after a crop has been harvested. So this gives you an idea of how much wheat is still left on the ground when severe lodging occurs. So picking this up is, you just can't get that low, especially with when you're dealing with rocks. So, typically we don't see this kind of impact throughout an entire field in moderate conditions, but under severe conditions, it can get this bad. Usually we'll see this kind of pressure around the outside of a field. We've seen pressure increase over the past few years. We've seen populations increase, and these are the kind of situations that we end up dealing with.
Okay, so Tyler, walk us through the life cycle, and Jay, maybe if you want to pop up a picture of the Sawfly. I think we have a few. Oh, there's the damage. Oh, we can go back.
That was the damaged pith. Ooh.
Yeah, the pith.
So that can cause some yield loss there, like Jeremy mentioned. So what you're seeing left behind is damaged pith, maybe some of the insect frass left behind by that larva. So it's living inside the stem till it goes and cuts that little hole for air conditioning. Might get hot in there. Mm-hmm. And then it's going to overwinter in the stem as well. So
so
that's
my question.
Near the base of the stem, though.
So it overwinters, and then when do they emerge?
So they're going to emerge in the springtime. They'll pupate in the stem, and then out comes the adult Sawfly, if you want to throw that picture up there. So this would have been, that's Jeremy's picture. Put my picture up. That's his iPhone
They're
picture.
Competitive, Jay. They're competitive. Yeah. All right.
So this is last couple weeks in June, first week in July. There's some of the wheat midge traps we failed to show.
Yeah, that's okay.
Those are wheat midge larvae. Beautiful.
We're getting there. We can go back.
Don't be confused, audience.
There we go.
There we go.
We're trying very hard. There we go.
So you're looking for those yellow legs. You're looking for that black body. Yes, it looks like a wasp and it wants to sting you. It is similar to a wasp. It's much closer to a wasp than that wheat midge is. So what she's going to do is she's going to use her Salt Lake ovipositor to cut a little hole in the stem and lay that egg, and then that larva goes and destroys the pith. And then, like I said, overwinters as a larva and starts all over again. Yeah.
So do we get the same sort of fun maps for this? What sort of monitoring tools do we have for Sawfly?
Well, Alberta puts out a fun map in the fall based on those cut stems. So basing it on the percentage of cut stems. So if you want to know what your economic threshold is for wheat stem Sawfly, you got to be in your field the previous fall and go for, what is it, like 30% cutting? Is that what it is?
It's around 10 to 15% where recommendation
10 to 15. Okay.
Yeah.
So
that
then,
means
and again,
that's
a survey again done by the great Shelley Barkley. So yeah, she runs around the province. Well, everything south of Highway 9 in Alberta, where she collects that data on wheat stem Sawfly cutting. I mean, even if producers are
more of a southern pest, eh?
They just. But I think, and if you and I know Haley Catton, she may want to correct me on this, but I think she said, by 2030, we may be seeing risks of that increasing north as we're seeing those warmer temperatures come in, and just seeing migration of wheat stem Sawfly move north. So, I mean, you can see there's kind of that yellow blob on the top left there, and you wonder, if there was more surveys taken north of there, would that blob continue up? So I think, I don't think we can cut it off as an option of not moving further north, and we'll have to continue to monitor.
I feel like now is a good time to let everyone know that Shelley is amazing, and I would love to have her on the show. She tells me a hard no every time. So it is not from lack of trying. She is amazing, but she likes to work behind the scenes and work very diligently. Lara, great point. Anytime you see Shelley looking for fields, retweet. Yes, whenever someone is asking, we need to get some traps out, I need some fields to scout, I need some whatever. This is the power of connecting with people and volunteering your sites, or to go out and do some of this. Anytime you see it, please do, if you've got the capacity to do so, because the more data points we have, the better information we have, and the better
Lindsay,
we can do on some of these. Yes.
I'll take this opportunity now that, Shelley reached out to me earlier on in the season and said that she is looking for producers this year that are okay with her coming into the field, collecting these samples. She's looking for midge across the entire province. So if you're in Alberta, and I won't speak for Saskatchewan because I don't know what's going on there, but if you're in Alberta, and you're okay with her collecting that information on wheat midge, she'd be happy to have you guys reach out to her, and maybe I'll share her contact information with you, Lindsay, before the end, and you can share that up. But and wheat stem Sawfly anywhere south of Highway 9, she's looking for fields that she can collect from. Yeah. So if you have her on Twitter, reach out to her. Otherwise, you could probably find her online on the Alberta website anyway.
But yeah, it's great. Now, okay, so but key point here, because Tyler, so unfortunately, so many things when we're trying to gauge, what it cost us, are after the fact, and we can't go back and change anything, but we can plan further ahead. So as you said, to really to go into your field after the fact and actually look at stem wise, how much impact, how much damage was there, how much yield you potentially lost. I mean, you can't go backwards, but how do you use that information going forward? Do you use that for adjacent field? Do you use it for when you come back to that field? Like, how much will these Sawfly move in the next year? Like, is it adjacent fields you have to worry the most about? Do they fly quite far?
Definitely need to worry about adjacent fields if they're coming out of your stubble. Like, look at the beautiful wings on that girl. She could fly pretty far.
Stunning.
Does she? Good question. But, as with any insect pest, if it's in one field, the adjacent fields are always next on their menu.
Okay.
So, now, what can you do? Wheat stem Sawfly and wheat midge, those are both things that our wheat breeders are looking for. So the two insect pests that wheat breeders care about are these two. And so they are breeding for resistance. So that's where the SM1 gene came from against wheat midge. And we've got solid stem or semi-solid stem wheat against wheat stem sawfly. So they don't do very well in that thick pith. They can't destroy it like they can in the more thinner stems.
Yeah, so let's dig into that just a little bit. It's not a gene or genetic expression of where they bite into it and it tastes icky and they starve. It's a physical structure of the plant that makes it less easy for them to lay the egg in.
That's right. It's like a physical action for them.
Sorry, you cut out there. Yeah.
Oh, of course I did.
Of course you did. So now we can fill
Never
the blank
happened before.
Yeah, exactly. And pretend that yeah. Okay, so it's a physical obstruction basically.
Yeah, it's a physical obstruction, yeah. And the larvae have trouble.
Okay.
And they don't survive.
So Jeremy, from an agronomist's perspective and in Alberta, and as Tyler mentions, we do have, of course, our wheat breeders that have been working on both of these problems. Is this something that is top of mind? Is it becoming more so because we're seeing such great losses? And do we have those great varieties to choose from?
Richard I love that
Richard's I love that Richard's on here because Richard is one of those breeders that's working to develop some of these wheat stem resistant varieties with solid stems. There is
he's in a good area for it.
He absolutely is, and I think it was Richard who put out a video here recently on Twitter of he had split a stem open, and you could see the larvae in there feeding. It is a priority. It is very important because there is no option for spray control. With proper scouting and monitoring in wheat midge, if you're not using that SM1 gene with those varietal blends, you can spray, which can help reduce the impact. And I know we didn't get into maybe emergence patterns of wheat midge as much as I would have loved to hear Tyler talk about that. But there is no spray control for wheat stem sawfly. There are management controls that we can put in place to help maybe mitigate impacts. Like obviously we want to reduce wheat on wheat situations. There is another beneficial that we're dealing with wheat stem sawfly, which is Braconcephi. So, in situations where there's high pressure, we want to be cutting higher, which, I always have these conversations with producers where we're seeing a lot of lodging and you have to dig really deep to pick that crop up. And they're going, okay, well, how am I supposed to be cutting at 15 centimeters? Because that's typically the range in which we see that. How am I supposed to pick this crop up while making sure there's still environment for that beneficial to live? So it kind of becomes a challenge. And the Braconcephi, and correct me if I'm wrong here, Tyler, but it survives better in those longer season environments where we have delayed harvest because it gets that second generation. And when we have that second generation, there's more that for control for the next year. But I sure we haven't forgotten what last year looked like, and it certainly wasn't a long fall. So we're likely this year not dealing with a high population of Braconcephi, or at least impacted in some way. So it just becomes very limited options for producers to manage that without some type of genetic trait that's going to resist that feeding and lodging.
Mm-hmm. Tyler, I'm so glad that Jeremy brought up this amazing insect.
Me
Describe to me, because this is one of my favorite insect stories. Describe to me how this parasitoid gets rid of sawfly, because it's super cool.
Well, any parasitoid is going to burst out of the body wall of its host,
of course,
just like the Alien movies. Am I dating myself there?
Definitely.
Explain the life cycle for those who haven't heard this story, because it's a good one.
All right. So Braconcephi comes along. Female's got a really long ovipositor, and she kind of pokes around in that wheat stem, looking for that wheat stem sawfly larva, lays an egg inside of it. That egg hatches and develops inside the wheat stem sawfly, and then at some point bursts out and consumes its host. So what you're going to get in that case is a Bracon cephi, and it's going to overwinter, but it was actually Scott Mears. He dissected 20, 30, maybe 40,000 wheat stems, and what he found was that Bracon cephi spends the winter higher up in the stem than its host does. So it crawls higher up in the stem. So that's why you want to cut your stems a little higher.
Yeah.
Yeah. Brian Barry does quite a bit of work on this as well.
Yeah.
So
now, Mr. Tate wants to know, is there a predator wasp that can be introduced? And I should have asked this for the Midge as well. Can I buy a jar of Parasitoid and be like, be free, go fix my field? What are our options for Sawfly in particular? Can I introduce this predator?
Not for Sawfly, but I mean, you do raise a good point. We do have some biological supply houses where you can buy predatory insects like parasitoids, but there isn't one that's selling Bracon cephi, to my knowledge.
Okay, get on it, please, if you wouldn't mind. One of you
Okay.
start.
It's got to be economical, right?
Yeah, exactly. But it is. I mean, we are seeing exactly that. We are seeing some of these beneficials or parasitoids being introduced in different areas. I know we've seen some work with nematodes in some areas. So I mean, we are seeing some of that type of options for insect damage, but of course not for the Sawfly. So we'll stay tuned. We'll wait.
I have a question on this, and like, I'm no insect ecologist, but if you introduce or add more Bracon cephi to an environment where it's already native, and it's environmental conditions that are essentially manipulating the population, including how much wheat stem sawfly is there for them to actually parasitize, would an introduction of additional really in the long term impact the population of Bracon cephi, or would it just be for that one season and hopefully it's worth the cost for that one season?
Well, what you're talking about there is augmentative biological control. So that is used quite a bit. Is it used for wheat stem sawfly? I don't think so.
Okay.
Right, we're talking huge acres of wheat, right?
Yes.
You
Yeah.
gotta dump a lot of Bracon cephi to make any kind of impact.
Tyler, I'm writing down all of the great words you were using tonight.
I'm trying not to use jargon, but
but the augmented. Keep talking. Anyway, it's fantastic.
Yeah.
All right.
The first one he mentioned was classical biological control. If you're taking notes.
Yeah.
So that's where
I take a lot of notes. Look at all these. Okay.
Yeah.
Mostly to try and keep things straight, like going to the second clip, which I did not do, and we don't have time now, so we're not going to go to it. But spoiler alert, Jeremy Boychyn was in it, so he's here now. We can just ask him the questions. I do, though, want to make sure. So Jay, if we can bring up the slide as one last shout out to our show sponsors, of course, Wheat Pete's Word, ADAMA Canada, and the Wheat School. Which, hey, sometimes Pete is on, sometimes Jeremy's on there. We've got some wonderful people on the Wheat School. You can go to wheatschool.com, and a big thank you to our Wheat School sponsors, Syngenta Canada, C&M Seeds, and the Alberta Wheat Commission. Okay, so yes, my notes did not help me, but I do have some wonderful new words and terms to use at the next dinner party to make me sound super smart. Mr. Tate wants to know, how about late applied systemic insecticide? So, okay, I want to take that question and actually expand it just a little bit more, because we talked a little bit about, okay, so for Midge, we have some insecticide options. For Sawfly, we don't, because of course they're inside the plant. But anytime we use an insecticide, they're not necessarily as targeted as, say, we're used to with maybe a fungicide or a herbicide. A herbicide maybe more so than anything else. So when we use an insecticide, do we have decent options that protect our beneficials or not? Tyler, I'll start with you.
Oh boy. Okay. Yes. Some of the newer chemistries are softer on beneficial insects. That is what they'll say. Have I seen that? I haven't researched it, so I'm not going to really qualify that with a yes, they sure are, because often those
Okay.
beneficial tests are done on honeybees and may not encompass all of the other field heroes that we've got out there.
Right. Shout out to our
So
field heroes.
maybe we'll throw it over to the agronomist who might have a better
Yeah.
agronomy answer.
There you go.
Yeah, I mean,
Jeremy?
when I think about late season applied systemic insecticides, I can't help but think about MRL considerations, and the risk there, right? The later we apply, and we do have some very short MRL or short pre-harvest interval insecticides, but no, they're not systemic. So this is systemic, as we're applying late on wheat, how much of it's actually getting up into the head. And, obviously this is well beyond anything that, I'm just kind of talking hypothetically here, but these are going to be considerations that we need to think about with something like this. There's nothing on label right now that can do that anyway. So until a registrar or someone comes up with something that can fit that need, it's not like there's a chemical sitting there waiting to be used that just isn't. So yeah, I mean, Mr. Tate there brings up. So this is certainly a tactic that producers can take, and seen it done where when the outsides of the field are more impacted, and you're starting to see those lodge over. Going in there and swathing the outside rounds to manage that before you lose that crop is an option. So going in as you're starting to dry down and potentially you're losing a little bit of the plump of that kernel by taking it down earlier, but it's likely better than the potential loss you may have. So yeah, that's an option as well.
Yeah, and to leave that stubble. So I was going to bring up the dreaded T word, of course, being tillage. So if we're talking about insects that live in the stubble, then if the stubble breaks down, do they get exposed to the elements and do we kill them or kill a number of them? Now, of course, with Sawfly, we know that the Parasitoid is in there too. So that doesn't work so well. But could that be an option with wheat midge? But then, of course, we're talking tillage, which, Tyler, you're in Saskatchewan. That's kind of a non-starter, really.
Well, there is some evidence that tillage does really well against wheat stem sawfly.
Yeah?
Yeah. It's in our AAFC bug book.
I need this bug book.
Yeah, you don't have the bug book? Well, its official name is really long. The show would end before I got the name out. So
right. Okay, no. Okay, so it is actually effective against sawfly, even though it would also potentially kill its parasitoid. It is effective.
Maybe. I don't think it does much against wheat midge. It may turn up the soil a bit and expose them to ground beetle feeding. But yeah, then it also exposes all of your moisture.
Yes. Yeah.
Yep.
Tillage is also always a trade-off, right? So, yeah.
Lindsay, I think I shared a slide that had a bunch of management options for wheat stem sawfly, and this actually comes up in there, not as aggressive tillage, but pre-seed residue management or fall residue management with a heavy harrow. So you see the second option down there. So this is something that was developed by Brian Barris. And as Tyler indicated, he's done a lot of research over his career looking at this. So this is kind of a management practice key that producers can look at depending on the significance of their wheat stem sawfly issue. So pest surveillance is obviously the first one on the list, and looking at those forecast maps and getting an idea of what you're dealing with and actually taking a look and seeing what kind of cutting you're seeing is going to be the first step in understanding what kind of management practices you need to take, bar none. And from there, when you get an idea of where your risks are and how significant it is, then you can start asking the questions of whether your management practices need to change. So low to moderate threat, a single pass harrow to manage the trash. But if you're in a little bit more significant pressure, then you can go with a little bit more heavy harrowing. And my understanding is that you're pulling up some of those wheat stems, you're dislodging them from the soil, and maybe killing some of those wheat stem sawfly. But inevitably, if you do have Braconcephy and you're dislodging that, you're likely going to impact them as well. So this needs to be part of the consideration, that if you're dislodging the home that holds wheat stem sawfly, you're dislodging the home that holds Bracon cephei. So I'm not sure if there's been a ton of research on looking at the impact of either, but inevitably I think there will be an impact on either. And Tyler, feel free to jump in if you feel like anything needs to be added there. Cultivar selection. Cultivar selection is going to be important, and you know, that's going to depend on where you are, and you know, typically you're going to be choosing between CWRS and Durham. Durham can be impacted greatly. You know, I've seen it in barley as well. Not that we have solid stem varieties, and I believe rye can be impacted as well. So typically we're seeing it in CWRS though. We used to have Lillian, but really some of the varieties we're seeing now have relatively similar control in terms of semi-solid stemness. So talking with your seed growers and seeing what options you have is going to be important. And then obviously seeding rate is going to be important, especially with CWRS.
So, I'm in looking through this. It's one of the questions that I didn't really even think to ask, but interesting to see that depending on what you're putting in there, a solid stem or a hollow stem, adjusting seeding rate can actually have an impact on the stem solidness. So that's really fascinating. That's pretty cool.
Yeah, there's some environmental effect on stem solidness. So it's not expressed all the time, or not well expressed all the time. So conditions are right. Interesting you brought up Lillian. That picture of wheat stem sawfly there, that was taken in Lillian. Yeah. I've got a field of Lillian.
There are some varieties that just are near and dear, aren't there? Lillian is one of them. I
think I got the last 2 bags in the country by the sounds of it.
Yeah.
Yeah, I know a few people that probably want on their hands on a few of those seeds, Tyler. So I wouldn't be talking about that too loudly.
We'll edit that part out, right, Jay? We'll just bleep it out. Now, I also want to say, and bless Prime Bears, but the meters, the 300 seeds per meter squared. How can, come on.
Oh, now. Goodness. Just take the 0 off and you're fine. Then you got per square foot. It's not that hard. I mean, it's not exact, but you're pretty darn close, right?
Close enough. Yeah, good. I like it.
We have to publish in meters.
Right? It's quite fascinating, actually, when, you know, what we use for acres and then hectares and then meters and then, yeah, exactly. Richard, thank you for this. Light intensity and pith development. Hexaploid is a tough one for high pith expression. I really appreciate that you are here. Yeah, that is.
And I think
we've got some good comments.
Yeah, I think this ties into that, because Durham, if I recall, is not a hexaploid, and seeding rate is not as important on Durham to get that pith expression. So this is really to that CWRS, making sure that your seeding rates are where they need to be in that 300 seeds per meter squared, or Lindsay 30 plants per square foot.
Thank you. Yeah. And AAC Concord is complete pith expressions with new ones, of course, on the way. I love it. The teaser. Richard, you're good at your job. You know that?
Coming soon.
That's right. And Peter Johnson, who does not want to be left out in the Smarty Pants Olympics, says Durham is a tetrapod. So there we go. I do appreciate so much everyone who joins us on this show every week, either as a guest or in the comments, because we all learn together. And it is always so wonderful to have some really fantastic people in the comments that can either take questions or ask the very tough ones and add some of that perspective. So I really do appreciate it. Okay, we are running out of time. Now we're getting into genomes. Peter, we don't have time for that. Okay. But to recap, next episode we'll get into the genomes. Yeah. Okay, I did want to send a shout out. We actually had Bolang Agro from Indonesia tuning in tonight. So hello to them. It's morning there, so good morning. And thank you to everyone in the comments. I want to, before we go though, we did mention, of course, that Shelley might be looking for potentially some fields. So anyone who wants to connect there, send me an email, lsmith@realagriculture.com. If you've got any other questions from tonight's episode, you can do that as well. And I think I really want to stress the importance, so I'll ask both of you, the importance of survey work and forecasting. Tyler, how important is that to what we learn in a year?
Forecasting is always important. Keep it up.
Keep it up. Let's do it. All right, Jeremy, even when the forecast is quite wrong, we still should be doing it.
Well,
yeah, I mean,
it's a
practice,
best guess,
practice,
right?
practice, right? If you're getting out there and you're doing it year after year after year, you get better at it. And I mean, there's no harm in going out and check. Should be checking your crops as often as reasonable anyway. And that's a great time when the head is popping out of the boot to see what's going on anyway. So, yeah.
That's the danger zone for wheat midge.
The danger zone.
The danger zone.
Tyler, before we go, do you want to show off your shirt?
Sure.
I mean, you don't have to, but there you go.
I'm wearing my Midge Buster shirt. Thank you, C-Can, for designing that logo. And
yeah, it is a heck of a logo. Yeah, I would. Hey, C-Can. Jeremy and I also like the logo. Just saying. Just putting it out there.
No pressure. No pressure.
No pressure. It's fine. Whatever. It's fine. All right. All right, Tyler, thank you.
You're welcome. Thank you, Lindsay, for having me on the show. Appreciate it.
Yes. And Jeremy, thank you so much for joining us tonight.
It was a pleasure.
We had some good comments there, hey?
I know.
Check them out. I think there's fodder for another talk there.
Oh, there most certainly is. And I do feel, I mean, by putting Wheat Midge and Sawfly together, I mean, they really each could have their own show. But sometimes it's nice to have lots to cover and bring in some of those good questions. So absolutely, we have a whole winter, you guys, to get through. So every Monday night, 8 p.m. Eastern, come on back. We'll tackle some more of this over the winter and talk more about some of those field heroes as well, because they're absolutely so important. So I will sign off. Thank you, of course, to our show sponsors, to ADAMA Canada, Wheat Pittsburgh, and the Wheat School. Thank you to my guests, and thank you to all of you joining us in the comments. Head on over to realagriculture.com/agronomists. Let us know that you took in this episode and get those CEU credits. And I will be back next week, and Peter Johnson will be joining me, and we're going to be talking about winter cereal establishment next week. So meet me back here and bring your questions. Cheers, everybody.